Alright guys, in today's video I'm going to show you how to find the surface area of a cylinder. So when we first started talking about surface area, we talked about lateral surface area and total surface area, and we looked at prisms, and pyramid nets where we were unfolding them, finding the area of each shape and adding them up. Then we moved on to look at the surface area formula on our math chart, and that was going to be S equals pH, or S equals pH plus 2B. So we looked and saw that we could actually use a formula, and we proved in those previous lessons why that worked. So now we're going to look at the surface area of a cylinder. So if you stop and think about it, a cylinder looks like a prism in a way, but your base is going to be a circle. So it's kind of like a very, very special prism. So the first thing what we did, before we even talked about surface area or anything like that, is we always shaded the bases. So if we had this, and we were to shade the bases, right? And we shade the base over here, and we shade the base over here. Well, the distance connecting those bases was the height. So your height is actually connecting the bases, just like what we did in a prism. Okay, so we're going to come back to those prism formulas to kind of understand that. Just in case you forgot, surface area is not only the amount of each shape, but so we could find the area of the circles, but this is like a curved rectangle all the way around there. So we don't have an area formula for this curved rectangle. So this is why we have a formula. Surface area, if you stop and think about it, is the covering of everything around it. So let's pretend that this is like a soda can, where this is the top and this was the bottom and then the foil around it. How much area does it cover? Or think about a present. So if you had like a prism, like a box, a rectangular prism, how much wrapping paper is wrapped around it? So how much of the area of each of those shapes? Okay, just in case you forgot what surface area actually represents. So in case we forgot, the diameter for a circle is from the outside through the center to the other outside. That's your diameter. And the radius of a circle is from the center to the edge. So that's going to be my radius. Okay? Definitely need to know that, because when we see these formulas, there's something very, very special we're going to see. Alright, so those are the different parts of a cylinder, and we are going to need to know that for our formulas. So let's stop and think about it. Think about what we've already learned with surface area for formulas. For lateral surface area, we said S equals capital PH, so the perimeter of the base times the height. And for the surface area, let me just make this a little darker for you. So S equals PH, and then over here, S equals PH plus 2B. Okay? If we stop and think, the perimeter of a circle is called the circumference. So that's everything around the circle. So when we look on our math chart, we said that the circumference equals 2 times pi times radius, or pi times diameter, because 2 times your radius still gives you diameter. Okay, we are actually going to use the 2 pi r part, and I'm going to come back with that. So basically of y. So the perimeter is the circumference of a circle, so we're going to say 2 times pi times radius. So the lateral surface area of a cylinder, you're going to say S equals 2 times pi times radius times height. So no matter what the cylinder is, you're going to do 2 times pi times its radius times height. I'm going to tell you why we don't use this part in just a minute. Alright, well, let's look at the total surface area. Again, perimeter of a circle is the circumference, which we already said was 2 times pi times radius. This capital B, remember, means area of the base. Well, the base we colored in was a circle, so that means we need the area formula for a circle. So the base of a cylinder is a circle, so we are going to use the area formula for that capital B. Remember, capital B just means area of the base. And when we look at our math chart, the area formula for a circle is pi r squared, or pi times radius times radius. So stop and think about it. If you need to know the radius for the area of the base, would it make sense for you to use the diameter over here? Let me zoom in on this to make it a little bit more clear. Sorry about that. Would you want to use diameter over here, pi times diameter, and the radius over here? That wouldn't make any sense. So on this, where we see the capital B, we're going to replace it with this part. Okay? So that means we're going to rewrite that formula based on what we know about the circle. So the total surface area, I'll kind of do this in different colors to help you out, is our lateral surface area first, perimeter of the base times height, which we said was this part right here. So 2 pi r h, because this 2 pi r, remember, represents the perimeter, plus 2 times the area of the base. Well, the base is a circle, so we're going to do pi r squared. So when you first look at these two formulas, 2 pi r h or 2 pi r h plus 2 pi r squared, they look a little intense and a little bit scary, but when you really stop and break it down, that makes sense, because here again, the perimeter of the base, the perimeter of that circle is the circumference, and that big B area of the base is pi r squared. So again, it makes sense if we're already using radius over here, we should use the circumference formula with radius for that perimeter. Okay? So your constants in the formula are going to be the 2 and the pi. Your variables, what are changing, is your radius and your height, depending on the radius and the height of the cylinder. Okay? So this is just something for us to think about of where these formulas came from. And that's what this next slide reiterates. So the results in the formula are on your math charts. Again, you don't have to memorize these formulas, but it's really important for us to understand where they came from. So lateral surface area is always going to be the first part of your total, but your total is going to be that little extra because here we're adding the bases. Okay? So we have to know the radius, which is halfway across that circle from the center to the edge, like in that first picture. So if they're giving you the diameter, well, this is a radius and this is a radius. So if you're given the diameter, you need to divide that number by 2. Neither of these formulas work with diameter, so we need to do that extra step to divide by 2 to know which number we're substituting in. Your h is your distance, your height between the bases. So just like a prism, your height is connecting the bases. All right, let's do a couple of problems together. So we're going to do 3 problems together before you practice on your own. As you are practicing these, you should be drawing these out, and if they're not already provided on your paper, you're going to be using your graphing calculator. Unfortunately, I can't share the calculator on here. It kind of, whenever I do, it kind of gives it a glare. So I'm going to show you how to type it in, but then pause the video, practice typing that into your calculator, and then press play again when you're ready to check your work. The more that you practice, that's going to help you guys out. So after you press play and let's say you get a different answer than I do, reach out to your teacher so we can see what you're doing and typing in into your calculator incorrectly, or maybe your equation was wrong. So that's what we always tell you guys to check in with us. So let's go ahead and get started. It says for each problem, shade the base and use the appropriate formula. The reason why you should always shade the base is that's going to not only help you to define what the height is of the cylinder or prism or whatever shape it is, but it also helps you to understand the different elements you'll need in that formula. So we're going to first shade the base right here. So this circle and over here would be the other circle. So there's 2 bases. The distance connecting those bases is 18. So that means the distance connecting my bases is the height of the cylinder. So that's my height. Well, let's talk about what this 6.5 is. This is from the center to the edge of the circle, so that's my radius. So I already know my radius and I know my height. So this question wants me to find the total surface area. So I need to use the total surface area formula. And I can look at my math chart or my previous notes, and I see that this is my formula. So I'm going to write that down first. 2 pi r h plus 2 and a capital B. All right. Now that we have everything labeled, we're going to do 2 pi My radius was 6.5. My height of the prism was 18 plus 2 times the area of the base. I'm trying to separate these colors to make it a little bit easier for us to see. So let's do this over to the side. Put this in purple. So the base of this is a circle. So we have to use the area formula for a circle. Pi r squared. Well, that's where I messed up. Got ahead of myself. Pi r squared. There we go. We already know that part. So that capital B is what we're going to replace there. Okay? So the pi was 6.5. Go over that in red. And my exponent is to the second power. I wrote down this first part, but I forgot to do pi r squared. I did the old part with the prism. That's okay. That's why we double check our work. So 2 pi r h plus 2 area of the base. Well, the area of the base I crossed out and said pi r squared because that's the area of a circle. So pause the video. Go ahead and type this in. So type into your calculator 2 pi times 6.5 times 18 plus 2 times 6.5 to the second power. Let's see what you get. So go ahead and work that out and come back when you're ready. All right, hopefully you've got to type that in your calculator. There's a lot of little elements, but when you type that in, you should have gotten 1,006 and my units are inches squared. Area and surface area are always to the power of 2 because you multiplied your inches over here. Inches times inches. Okay? If you did not get that, you can stop the video, reach out to your teacher before coming back to this, or continue the video and see, maybe try it again where you might have made a mistake. Okay? Let's do 2 more together before you practice on your own. All right, so same thing, no matter if it's a prism or a pyramid, the first thing we want to do is shade the base. So if I shade the base, got these bases right here. So this is a cylinder because the bases are circles. The distance connecting those bases is this 16 meters. So in a prism or in a cylinder, the distance connecting the bases is always the height of that prism, or in this case, a cylinder. So again, think about this cylinder just kind of as a curved prism, and that's why those formulas look almost similar, but why we related to where it came from. So let's talk about this 14 meters. This is going from the outside of the circle through the inside to the other outside. So if it goes through the center, connecting the edges, that's the diameter. Okay? Well, this question wants the lateral surface area. So that means lateral, just your sides. That means everything but the bases. So we're going to use this formula because it's a cylinder, and we just want the lateral surface area. So lateral surface area equals 2 pi r h. Important to know, when you see on your math chart, you just see S, and then this is S. I just like to write that extra LSA for lateral surface area or TSA for total surface area, just so it helps me remember what I'm looking for. We don't need to add this additional part because that's including the area of the bases. We don't want that. All right, so let's go ahead and plug in our numbers. 2 pi are constant. My radius is what I need to know, but I only know the diameter. So to get from radius, or from diameter to radius, I should say, that's where we divide by 2. So 14 divided by 2 is 7. So I am not using 14 in my formula, or my equation, excuse me. I'm using 7. Okay? If you do everything else right, but you actually put 14 here, you're going to fall for a trick answer. Okay? So that's why we always want you to go through this consistently, show your work, and label what you need. The height connecting those circles is 16. So 2 times pi times radius times the height. Okay? Here again, that makes sense because if this is 7 from the center to the edge, And this is 7. 7 times 2, or 7 plus 7, gives you that total 14. So that's why we need a 7 here. We don't want the diameter, we want the radius. So go ahead and substitute that in your calculator. Let's see what you get. 2 times pi times 7 times 16. So this is the formula. You make it an equation when you substitute those numbers. So see what you get, and then when you're ready, come back and see what you got. All right. So when you did this in your calculator, you should have gotten something along the lines of 703 and 717 thousandths, and it might have kept going. But, very important to read the directions, this one says round to the nearest tenth. So we're going to go to the tenths place. So we need to decide if that 7 is going to stay a 7. So your little rhyme, if you go to the 7, the tenths, you actually need to look at the hundredths place, the one right next to it, and only that number, and say 4 or less, let it rest, 5 or more, add 1 more. So that's 4 or less, so we're going to leave it alone. Just a little rhyme when you have to estimate. So this is going to stay at 703 and 7/10, and my units are meters squared. Again, if you did not get that answer, you can pause the video, reach out to your teacher, and we can help you out. But I can most likely guarantee you, if this was multiple choice, if you did 2 times pi times 14 times 16, that most likely is going to be a trick answer. Okay? And I talk about trick answers in these videos to kind of help you prepare for what you might see. All right, let's look at number 3, last one together. Determine the total surface area. So they want the total surface area of a water tank with a height of 10 meters. They've already told me the height. And a diameter of 8 meters. So my diameter is 8 meters. Okay, well first, if they don't give us a picture, we can go ahead and draw one out. Okay, draw a cylinder and label. Doesn't have to be perfect. Get you the idea of it though. Mine's a little crooked, but that's alright. So they told me the height, the distance connecting those bases right here. They already told me that was 10 meters. My bases are circles, but I also have a diameter of 8 meters. So diameter goes all the way across. Color kind of around that so you can still see it. Okay, and I want total surface area. Again, don't have to memorize these formulas, just need to know how to work with them. So that's my formula I need to start with. So total surface area equals 2 pi r h, because that's just your lateral surface area, plus the area of the bases, 2 pi r squared. This number 2 is there because the area of one circle is pi r squared, but we have 2 of them that are equivalent, so that's why we're doing 2 times that amount. Go ahead and plug in what we know. 2 pi, the radius is what we need here, but they give us the diameter, so 8 divided by 2 is going to give me my radius. So that's what we're going to use, 4 meters. Okay, we did need that diameter to figure out what the radius was, but that's not the number we're going to use in the equation. So formula is your standard, what you're looking at. Your equation is when you're substituting the numbers using for that problem. So the radius of this circle is 4. The height of this cylinder is 10. And then we're going to say plus 2 pi. I know this red is really close to that pink, but that's my radius color, and this is just me showing my work. So 4 squared. And just like what we did in class, if you'd rather say pi times 4 times 4, so it helps you out, but if you want to keep using that exponent, just to help you out using that graphing calculator. All right, so again, there's a lot of little steps in here. 2 times pi times radius times height of the cylinder plus 2 times pi times the radius to the second power. So plug that in your calculator. Let's see what you get. And then come back and see what I got. Check your work. All right, hopefully you've had some time to do that. This one did not ask me to round to the nearest tenth, hundredth, or thousandth, so we'll just go ahead and go to the nearest thousandth. You should get 351 and 858 square meters. All right, I know there was a lot of detail in this video, but you can see that there's a lot of detail in these formulas, so we wanted to make sure you understood why these represent what they do, and that way checking in with your work. So if you have any questions, make sure you ask your teacher so that we can further help you out. Good luck.